Alright, so this is triangle congruency proofs. We're going to use SSS and SAS first. These examples on this sheet, we're showing you an example of each one, and it's going to be obvious to you what the answer is going to be once we finish. The thing is, we're just giving you examples of each one. When you get to your practice and your home learning, you won't know what the answer is going to be. You're going to have to figure that out for yourself. But by the time we get through these examples, you should be able to figure out how to mark a proof up and then figure out what the triangle congruency they're trying to show you is. Alright. So starting out, side proofs. It says if all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using fewer parts. The first one is using side. We talked about that on Friday. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So in this case, and they show us this out to the right, and we can write statements based off of this. If segment AB is congruent to segment DE and segment BC is congruent to segment EF, and then if segment AC is congruent to segment DF, then triangle ABC will be congruent to triangle DEF. So if we know that all these sides are congruent on both triangles, then we know these two triangles are congruent. This is side congruency. Alright, I'm going to show you what a proof looks like side. And I'm going to walk through slow. Oh, other thing you need to have out, and I told y'all to bring it back when we went on Friday, your reference sheet from Friday. You need to have that out. I'm going to keep referring to that. So I'm going to give you a second if you don't have it out, because you're going to need it. We're waiting on some other kids to get that out on the bottom of the reference sheet. I told you. We got a little, well, it's called a reference sheet for a reason. We got a little chart down here. We got reasons sides are congruent. We got reasons angles are congruent. And then we got other. Just some more information that you could use on a proof. But these are the main reasons we're going to use here, based on what we mark up in our figure. And based on us marking sides or angles. Make sure you have your reference sheet out, because I'm going to keep referring to the reference sheet. Alright, so in this first proof, it's a sample SSS proof, side proof. It says fill in any missing statements or reasons. The key thing on the proof is what they start you out with, which is called given information. They always give you something. They'll either give it to you in writing, or they'll actually mark it on the figure. If you look at this figure over here to the right, these two triangles connected in the middle by vertical angles, they didn't mark any sides or angles congruent on there. So we'll have to do all that for ourselves. But they did give us information over here that we can use, and we can mark that on the proof. And it's called given information. They always start you out with something. Now, they might start you out by saying it over here, or like I said, they may actually mark it on your figure. You may start out with your figure having some marks on it, whether it be two sides marked congruent. That's still given information. They'll either give it to you in writing, or they'll actually mark it on the figure. In this case, they gave it to us in writing. They didn't mark anything on the figure, but sometimes they will. So you just got to be cognizant of that and understand that that is given information. So reading the given information, it says segment JL is congruent to segment NM, excuse me. And it says K is the midpoint of JN and LM. Then it says prove triangle JKL is congruent to triangle NKM. If that's the case, they want me to prove that. So I'm going to start by, and on this one, on this proof, all my reasons are missing. And we kind of go to the extreme with y'all just so y'all be prepared when y'all get asked to solve for proofs. But when y'all doing it on a EOC or anything on a test, more than likely you'll only have a couple things missing. It won't be all the reasons missing. It may be one or two, or it may be one or two reasons and then one of the statements is missing. You won't have to do the whole proof on a test or anything like that. But we teach you how to do the whole proof so you'll be prepared when you get on the test, and it should be easy for you to figure out what's missing. So the first statement down here is JL is congruent to NM. That's a statement. I got to provide a reason why I know that statement. And the reason for this one is simple. If you look on your reference sheet, it's on there too. They said a side was congruent to a side. On the reference sheet, you got 3 reasons that sides might be congruent. It's given, definition of a midpoint, or reflexive property. We'll get to that when we see it. In this case, I know JL is congruent to NM because they gave me that information. So just write given in there. This is given information. After I write that in, I'm actually going to mark that on my figure. It said JL was congruent to NM. I'm going to mark those 2 sides as congruent, this and this. My bad. I'm marking that information on my figure. Bronson. From Bronson. Yes. Alright. Zoe go to Gold House. I guess you're coming back though. Yeah, hurry back, you're gonna miss this. The next thing it says K is the midpoint of JN and LM. K is the midpoint of JN and LM. How do we know that? We know that because it's given information again. They told us that at the top. Now, here they told us K is the midpoint. They didn't tell us any sides, anything was congruent, but we know now that this point K is the midpoint of these 2 segments. What do we call it? JN and LM. I was reading the next line. I'm tripping. Alright. From there, the next line. And I'll tell you this. Anytime they start making these kind of statements in a proof, after that, you're going to have to tell why you know why that statement is true. And it's something I've been asking y'all all year. I asked y'all this earlier in the bell ringer last week, too. Some kids should know the answer to this. But, so we said K is the midpoint of JN and LM. Like, the next line says JK is congruent to NK. Tim, how would I know that segment JK is congruent to segment NK? Because K is the midpoint of JN, right? So, look at your reference sheet. What reason would you use to say that you know that JK is congruent to NK? Definition of a midpoint. It says a midpoint will create 2 congruent sides. If that's the case, this is the definition of a midpoint right here. And once you do it, anytime they call stuff congruent, you need to mark it on your actual proof. They call JK congruent to NK. I'm marking that on my proof. JK is congruent to NK. Next line says LK is congruent to MK. LK is congruent to MK. Why would I know that, just say, yeah? Mm-hmm. K is the midpoint of that line segment too. If that's the case, what's your reason for? Definition of a midpoint. You can use the same reason twice if you need to. We're marking those congruent as well. They said LK is congruent to MK. Now I work my way through my proof, and now I get to the part where they're telling me a triangle is congruent to a triangle. At this point, this is where I want to give one of my congruencies, and I'm pretty much finished on this one. But the triangle JKL is congruent to triangle NKM. If you mark your triangle correctly, it'll be obvious. Now I know I told you at the beginning that was an example of a side one, but like I said, when you get to your own paper, you're gonna have to mark your proof correctly and then figure that out for yourself. But if you mark your stuff up correctly, you should easily be able to see that they're showing you side congruency. Yes, I hope so. So last line, I know these triangles are congruent because of side. Somebody knocked on the door. Y'all not gonna open it? I see who it is. Thank you, Quitter. Moving on. Let's increase our pace. Next one, side angle side. Says the two sides that include an angle of one triangle are congruent to two sides that include an angle of another triangle, then two triangles are congruent. Y'all know this already. I'm just gonna make my statement again like I did on the front, but I'm using side angle side now. So side angle side. If segment AB is congruent to segment DE, and then angle B is congruent to angle E, then segment BC is congruent to segment EF. All I'm doing is looking at the stuff in the picture and writing that down. Not bad. Then triangle ABC is congruent to triangle DEF. That's side angle side congruency. So I'm going to explain that to you. Alright, so number 2 is SAS sample proof. Fill in the missing statement or reasons on this one. So now we got a statement missing, and then we got some reasons missing. The proof starts out, it says given JM is congruent to LN. Then they say angle JMN is congruent to angle LNM. They want us to prove that triangle JMN is congruent to triangle LMM. Alright. So, starting out the proof, the first statement they give us is JM is congruent to LN. Devin, what reason are you going to put there? Given. And they call those congruent, so we need to mark those. If I ever forget, remind me, because sometimes I forget and I have to go back. JM is congruent to LN. Then after that, Parker. The next line, our statement is missing, but the reason is given. What would you write there for your statement? Okay, Devin, come back to you. Yeah, it's congruent to angle LNM. Parker, Jeremiah. Bro, this is given information. It's going to be written at the top most of the time. All you got to do is copy and paste, man. I'm not trying to trick you right now. So they call those angles congruent, so we're going to mark those angles congruent. This way it gets tricky for some of you kids. Y'all have trouble marking angles still. JMN, that angle. The angle is where it forms at which letter? M, the middle letter, right? J and N just help you decide what side it's on. Once you say JMN, I know it's on this side. If I just say angle M, I don't know if you're talking about this angle, or the whole thing. When I say JMN, I know you're talking about this angle right here specifically. That angle. I'm marking that one. And then the other angle they say is LNM. LNM, which is here. They call those two angles congruent. They told us that. The last thing they tell us is that MN is congruent to NM. MN is congruent to NM. And say MN is congruent to NM. How do they know those sides are congruent to each other? Go ahead.
Reflexive property.
Well, that is true. I didn't want to know the reason, but how do you know just in general that those sides are congruent?
They share the side.
That's exactly. The two triangles share that side, right? Hope everybody can see that. The two triangles share the side MN and NM. Now they called it like that for a reason too. So Tim is right about this being reflexive property. If you look on our reference sheet, for a reason sides are congruent, and we're talking about congruent sides right now. It says reflexive property. A side is congruent to itself, which is true. The MN is congruent to itself, but we call the other side NM because based on the way the triangles are named. Like, and I told y'all this matters, how you name one thing versus the other. These triangles, they're reflexive of each other, but this triangle JMN is kind of a rotation of this other triangle LNM. It's not really a reflection or flip over. You couldn't flip this over and land on itself. You would have to rotate around and land right here on this side. So what I'm saying is, y'all know how we talk about naming triangles correctly. It's based on the way you name them. If you can look at the triangle statement up here, that'll work. This congruency statement for the triangles, what we're trying to prove, they called it triangle JMN is congruent to triangle LNM. On that first triangle, just looking at the statement up here where it says prove, MN matches up with what? I'm asking. MN matches up with what on the other triangle? NM. That's just because of the way they're named. So you would have to write it like that in your statement. If you wrote MN is congruent to MN, you will be wrong. Because this reflexive is the flip. And you'll see one on one of these other proofs that we'll do where they'll be both named the same way. You have to kind of pay attention to that because we will test you with that, seeing if you know the difference. This is one where the reflexive property is kind of a rotation, and there'll be another one where it's more so of a. Oh, I can show you right here. We're about to get to it next. On this next one, this is reflexive property right here with QS, but in the statement, Q and S are in the same spot on this one. You see? So this reflection will be QS is congruent to QS. And because if you look, this looks more like a flip, yes? It looks like I could flip this over and QS would still be in the same spot. On the one that we're doing right now, if we were to flip this image, they wouldn't be in the same spot. You have to rotate this around. This is more of a rotation than a flip. But it's still reflexive. They still share their side. They land on each other, but it's MN is congruent to NM. That's the difference between the two. And you have to write it like that. If you don't write it like this, you're going to be wrong. If you write MN is congruent to MN, you're going to be wrong. On the next one that we do, if you don't write that correct, you're going to be wrong too. Alright, but I agree with Tim on this. This is reflexive property. Reflexive. This is the easiest one to spot too. Anytime they share a side, just know that you're talking about reflexive property. I think we will hit you with that one on the test too. Don't get it wrong. It's too easy to get wrong. Anytime they share a side and they're telling you something that's congruent to itself, it's reflexive property. You need to mark that on the actual figure too. Huh? Alright, so we worked our way through now. Triangle JMN is congruent to triangle LNM. If you look at the figure the way we marked it, you should read side angle side congruency. SAS. That's a side angle side proof. Moving on. The next one, angle side angle. It's if two angles and an included side of one triangle are congruent to two angles and included side of another triangle, then the triangles are congruent. So if angle, side angle, so if angle A is congruent to angle D, then side AB is congruent to side DE, and then angle B is congruent to angle E, then that means the triangles are congruent. ABC is congruent to triangle DEF. Then we have a sample ASA proof on this one. So it starts out with our given information. It says given segment SQ bisects angle RQT and angle RST. And then they want us to prove that the triangles are congruent. Triangle QRS is congruent to triangle QTS. So on this one, alright, it starts out with the first statement is SQ bisects triangle RQT and angle RST. Jeremiah, come back to you. What's the reason? You can't be this lost, man. Huh? Given. Yeah. Now I will tell y'all this. Anytime you see them talking about something bisecting something in a proof, you're going to use the logical reason after that. And if you see they gave you the reason for number 2, which is definition of an angle bisector, which is down here in our reference sheet. Reasons angles are congruent. If they talk about angles, look at your reasons for angles. So though they mentioned 2 angles being bisected in the first one, we need to mention that. The second reason is definition of an angle bisector. I'm going to give you the statement because I don't think nobody will be able to get this one. Not yet. The first angle that they mentioned was RQT. So that's the one I'm going to look at. Angle RQT, this big angle right here. RQT, that's this big one. If that gets bisected by segment SQ, what does it create? I'll tell you this. It creates 2 congruent angles. Can anybody name the 2 congruent angles that it's going to create? Nope. Those are not angles, but those are sides. But thank you. Yeah, that'll work. Good, Billy. I'm going to say the first one you said first. So Billy said it's going to create the 2 congruent angles, angle SQR, which is congruent to angle SQT. And I'm going to mark those for you too, for those who can't see it. Like I said, they said SQ was a bisector and it bisected angle RQT. That means it could create 2 congruent angles here and here. SQR is this first one she named, that's the one on top. And then SQT is the second one that she named, that's the one on the bottom. You need to mark those 2 angles congruent. And I do stagger my angle marking so you can see I'm marking 2 separate angles. That's why I stagger them like that. And that's the definition of an angle bisector. If SQ is a bisector, then that means it's going to split that angle RQT in half. And you have to name the 2 angles that it's split in half congruently. The next one says angle RSQ is congruent to angle TSQ. What reason would you give for that, Torres? You want me to mark those angles for you? Let's mark those angles first. It says angle RSQ. RSQ, that's this angle right here. It's congruent to angle TSQ. That's this one right here. What's the reason we know those 2 angles are congruent? Yeah, it's the same reason. Definition of an angle bisector. That's the other angle that they talked about splitting, angle RST. So this is definition of an angle bisector as well. Trick to these proofs. If they mention splitting two different angles, go ahead. On this one, they mentioned splitting two different angles on this one, so I know I'm going to have to mention definition of an angle bisector twice. I just know that, just because they talked about two different angles that were being bisected. So I'm going to have to explain about the two different angles that get bisected in my proof. I just know that just from reading the top. Just make sure it flows correctly. Don't make up something that don't make sense. Like, I would have kids last year and the years before. It would start out talking about some angles being bisected, and then they go down here and mention definition of a midpoint. That doesn't make sense on this proof. One, you're not talking about sides. You're talking about angles. And then two, they never even mention anything about a midpoint. I told y'all, common sense course, use common sense. Don't mention nothing that ain't been mentioned to you. Don't talk about no definition of the midpoint and they ain't tell you something was the midpoint and something else earlier. Y'all understand what I'm saying? Well, some of y'all do. Use some logic. That's what I'm asking you to do. Don't be illogical. Don't just make up stuff because you think that sounds good. Don't mention nothing that ain't been mentioned to you. Number 4. The statement is missing, but the reason is there. It says reflexive property. Jalen, what would you put for your statement? This is what I was talking about on the last problem. You gotta make sure you do it right. And you can look at the triangle congruency to let you know how to call it out. Go ahead, Tim, because we ain't got all day. QS is congruent to QS. If you do SQ, that's going to be wrong. Like I say, this reflexive property is more of a reflection. The last one that we looked at was more of a rotation that landed on itself. There's a difference between the two. QS is congruent to QS. Then after we need to actually mark that on our figure. So marking those sides congruent to each other. Just put one mark in there, one side marking. And then that shows you your angle side angle congruency, ASA. Alright, moving on because I want to finish my notes. Next one, angle side. It says the two triangles and the non-included side of one triangle are congruent to two triangles. Two angles and the non-included side of one triangle is congruent to two angles and the non-included side of another triangle. Then the triangles are congruent. Yeah. Angle side. While we're doing this, taking this information off the triangles, writing it over here like I've been doing. So angle A is congruent to angle D. Then angle B is congruent to angle E. And then side BC is congruent to side EF. Then you have triangles congruent. ABC is congruent to triangle DEF. All I did was take the information from the left, put it on the right. Rolling. Finish this off. Alright. Number 3 says given YZ bisects angle WXY, and then after that it says angle YWZ is congruent to angle YXZ. Let's get somebody to walk me through this one. Tali. Number 3. No, I don't worry about her. She stays asleep. Don't worry about you. So they gave us that information, Tyler, and they want to prove the triangle WYZ congruent to the triangle XYZ. First line, Tyler says YZ bisects angle WYX. What's the reason for that? Yeah, given information. Now I want y'all to notice on this one, they skip a line. Our givens are not right under each other. Your givens won't always be right under each other, and they always won't be in order too. Sometimes you have to look based on the second line and decide which given you're supposed to write in if your given is missing. And I'm going to show you that on an example later this week. But don't always think your givens will be in order, and don't always think they'll be one after another. On this one, so that was a given piece of information. Entirely, the next line says definition of an angle bisector. So they told us YZ bisects angle WYX. Then the next line says definition of an angle bisector. Name the 2 angles that would be congruent based on the first line. Good. I didn't think you was going to get it. Excellent, sir. Angle W, hold on, let me write it right. YZ will be congruent to angle XYZ. And then we need to mark those for the kids too so they can see them, because some of these kids don't see it still. If you see it already, mark it before me. Don't wait on me. They're showing you that this angle is congruent to this angle. And those are 2 Tyler just called out. He named them correctly too. WYZ is congruent to XYZ. Excellent, sir. That is definition of an angle bisector, because they said YZ bisects angle WYX, that big angle. The next line, Tyler, is given. What I need to put there? This ain't no trick, man. The next line is given. What do I need to put there? Jesus Christ, man, this ain't no trick. Don't ask me no questions. Tell me what to write. You were doing so well, too. Savion, help him out real quick, and we'll come back to him, because I'm not done with him yet.
Angle YWZ is congruent to angle YXZ.
Just the given information, bro. And don't overthink this. You're going to blow your head up. The main thing y'all need to do after that is make sure you mark the right angles. They already called those angles congruent, so mark those angles. YWZ, mark that angle, congruent to angle YXZ. And make sure you show that on your figure so you can see it. After that, YZ is congruent to YZ. I'm back to you, Tylee. Why is that? Why are those 2 sides congruent? This is sides now. Use the reference sheet if you have to, man. It's sitting right there. I told you it's a common sense section, right? Angle bisector. If you say definition of angle bisector, I got to be dealing with 2 angles. Are these even angles I'm talking about right now? So why would that even make sense to put that? But stop guessing. I'm saying the side is congruent to itself. YZ is congruent to YZ. Oh, Alexis. Reflexive property. You talking about she sleep, you sleep. You sleep at the wheel, bro. I'm handing it to you, dog. After you do that, make sure you mark that on your figure, because they call those congruent. YZ is congruent to YZ, so it's congruent to itself. After you do that, you should be able to read the right, what you call it. Like I said, I know we telling you what these are starting out, but I'm showing you that if you mark correctly, you'll be able to read your congruency statement. Angle, angle, side. I'll read your congruency, not a statement. Last but not least, HL. Hypotenuse leg. Remember, for hypotenuse leg, it has to be the hypotenuse in one of the legs marked congruent. So if the hypotenuse and the leg of one triangle is congruent to the hypotenuse and the leg of another triangle, then the triangles are congruent. Yeah. Has to be a right triangle. Then you have to have the hypotenuse, which on this one is BC. Segment BC is my hypotenuse, congruent to segment EF. And then I have to have one of my other legs congruent, which in this case was AB. It's congruent to DE. And if that is the case, then triangle ABC will be congruent to triangle DEF. Yeah. Let's roll. Last one. So on this one, oh good. Let's get into some of this. It says given. Rama, help me with this one. It says given MP is, what's that symbol right there, Rama? I'm sorry? No. Oh man, haven't taught you well. Billy, what's that symbol? Devin? Yeah, perpendicular. I don't know why we don't all know that. MP is perpendicular to LN. Anytime I hear perpendicular, I start to think that they're trying to talk to me about right angles in a proof. And if you look at the next line after that, you see that they start talking about right angles. Anytime they start talking about perpendicular, they want me to know about right angles. Just an FYI for you guys. MP is perpendicular to LN. Then after that, they said segment ML is congruent to segment MN. And then they want me to prove triangle LMP is congruent to triangle NMP. Alright. So, Ram, I'm still coming back to you because I haven't lost faith in you yet. MP is perpendicular to LN. What's the reason for that? That is given information. Yes, it is. And they already showing us that on there. If they weren't showing y'all that, once they tell you that MP is perpendicular to LN, if they didn't have right angle boxes here, I will put them in myself. But they already got them there. I may put the one on the end on the other side, but just know that those are right angles. And then they tell you that. They say angle MPL and angle MPN are right angles. Raman, look at your reasons angles are congruent. Tell me which reason you would give. Is it in there? Let's see if you can figure that one out. Oh, did we change it? No, we didn't change it.
No idea.
I feel like we changed this proof. Oh yeah, there it is. I'm tripping. Thank you, bud. I thought it wasn't. I thought I was missing it. Yeah, it's in there. Good job. It's in the other category. I'm sorry, bro. I'm sorry, Rama. And Tim got it. We called the two lines perpendicular at the beginning. This is definition of perpendicular lines. Thank you, Tim. You saved me. I'm about to be confused. Might have to abbreviate on this one. That's a lot to write in there. I might write def of perpendicular. That was one of our ones in our other category. Good. Alright. My bad. So he's absolutely correct. We know those right angles because that's the definition of perpendicular lines. Perpendicular lines create right angles. Then after that, I think I could bring you back, Rama. This one, next line says reflexive property. What would you write on this one? Mm. A little bit louder. Mm-hmm. Yeah, MP is congruent to MP. Congruent to MP. My bad, didn't know I wasn't showing y'all that. I'm so zoomed in right now. Let me zoom out a little bit. We can mark that on our figure. That's one of our legs. Then the next line says given, Rama. What else was given? ML is congruent to MN. I'm going to mark those congruent as well on my figure. And then obviously once you finish marking, you can see that this is HL. Congruency. I never trust in y'all, so hold on. I know y'all not where I need you to be. I need that one. I'm just deciding which two I'm about to do on the back. I mean on your practice. That's a good one to do too. Maybe we'll do 3. Yeah. I don't want to leave y'all stranded, but I don't want to do all the work anymore either. Tim, you've been doing good. Let's see if you can do number 9 with me. Yeah. I'm on the practice page. Y'all still gonna do this other stuff? But I want to do a couple more. I don't trust y'all yet. Some of y'all I really don't trust. Tali. Number 9. So it gives you this information up top, Tim. Then it says prove triangle ABD is congruent to triangle CDE. You got statements and reasons missing. See if we can go through and fill this out. Number 1, what statement would you put in there, Tim?
Segment AB is congruent to segment CD.
Yeah. Remember, anytime you call stuff congruent in your proof, make sure you mark it. AB is congruent to CD. After that, Tim's statement, AB is parallel to CD. I'm waiting on Tim.
I'm stuck between.
Don't be stuck on this one, Tim. Look at the top.
Oh, that was good.
This is given. Yeah, I feel you. I looked down at first too at my reference sheet, but this one's given. So it's telling you AB is parallel to CD. Y'all might want to mark that on here. I showed y'all this when we did our proofs the other day. I told y'all when we start talking about parallel lines, you got to start thinking about stuff we know from the past. That's my little parallel arrows. They're not that good, but whatever. That's saying those two sides are parallel to each other. Next line, Tim, it says angle ABD is congruent to angle CDE. So they call those angles congruent, Tim. Before you try to think of a reason, it's best to mark those angles on here. Mark those angles on your actual figure. And I'm talking to everybody. Mark your angle. Angle ABD and angle CDE. Angle ABD would be right here. Angle CDE would be right here. Good, Tim. They told us to mark those angles, and they want to know the reason why we know these angles are congruent. Tim just told you guys. Tim just said those are corresponding angles. How does he know? Because these lines are parallel, and these are corresponding angles on parallel lines. The next line says given, Tim. D is the midpoint of BE. Uh-oh, I missed the whole word there. Hold on. Midpoint of segment BE. Alright. The next line, Tim, says definition of a midpoint. I agree. Make sure you match up using the triangle statement there. So say it again. Yeah, BD will be congruent to DE. BD will be congruent to DE, and we can mark that on our actual figure. Side BD, there's two markings because we already got a side mark. It's congruent to side DE. Based on the way me and Tim marked up, Tim, why are these two triangles congruent to each other? Side angle side congruency. You're going to have to mark your figure to be able to figure it out. I used to have the kids last year that didn't put nothing on their figure, and they would try to tell me a congruency. That's how I knew they cheated. I said, you can't sit there and have nothing on your actual figure and then you know the congruency. You ain't that smart. I know you ain't. I can't do it without it. Good. That's one. Thank you, Tim. That was good. Who else I need to put my trust in? Torres, this seems like a good one for you. Let's do number 10. I want to do these parallel line ones because we ain't had none of these in our examples. And then I don't know which one I'm going to do after that. Maybe I'll do 11 too. Yeah. That's good. They need to see this on the recording too, these kids who didn't come to school. JK is parallel to LM. JL is parallel to KM. Prove triangle JKL is congruent to triangle MLK. Alright, so Torres, the first line of the proof says JK is parallel to LM and JL is parallel to KM. That's given information. We do, the same way we mark perpendicular on our proofs, we do still want to mark parallel on our proofs. But understand, this is not saying these sides are congruent, they're saying they're parallel, so you should have arrows. So JK is parallel to LM, and then also they're telling you JL, and I'm going to double my arrows up too to show you parallel a different direction, is parallel to KM. I'm just showing you parallel on here. I'm not showing you when you get ready to read your congruency, do not read these parallel arrows as side markings. Understand the difference. These are just parallel arrows. You're not saying these sides are congruent. You have to still prove that. Alright, so they told us all that, and then they said this next, Torres. See if you can figure it out. They say JKL, that angle is congruent to angle MLK. Before you try to figure out what it is, mark those angles first. Since they called them congruent, we can mark them. They said angle JKL, that's this angle right here. It's congruent to angle MLK. Torres, do you know why those two angles will be congruent to each other? Can't remember if you was here for this or not. You might not have been. It might have been after you came. Before you came. Oh, Parker, you know. Jeremiah, you know. Good. Alternate interior angles. So this might have been before your time, which is okay. Alternate interior angles. Then after that, they said angle JLK is congruent to angle MKL. I'm marking those angles as congruent now. What's the reason for that, Jeremiah? I'll come back to you. There ain't no trick, but come on, man. What's the last thing you told me? It's just the ones on the other side, man. Alternate interior angles still. I know, but I'll be trying to work with you. These are alternate interior angles as well. Y'all should notice them as that. That's the main reason they mention parallel on this one. So, as I used to tell my kids before, anytime they mention parallel in the proof, you're more than likely looking for one or two things. Alternate interior angles, like we have on this one, or on the last proof that Tim did, depending on the way the triangles are facing, you're going to be looking at, hold on, let me scroll back up. You're going to be looking at corresponding angles. Anytime they start mentioning parallel in the proof, think about those. Think about the fact they're trying to show you either alternate interior angles or corresponding angles. You just got to mark them and see which ones they are. Then the last thing on this one says reflexive property. I shopped this one out. What's the reflexive property on this one? Good. KL is congruent to LK. Specifically that way. You have to say it that way on this one. This one is a rotation. KL is congruent to LK. You can look at the statement and see how they wrote it in there too. This one is not a direct reflection. They do share that side though. So sharing that side, we will mark that as well. And then Torres, the triangle JKL is congruent to the triangle MLK by what? The last line. Why are these triangles congruent? What do we prove? Angle, side angle. ASA. Last one I'm going to do, I promise. I just don't want to leave y'all stranded. And I'm being nice about this. So you better do my homework. I know that for sure. On this one. This is what we call a paragraph proof. We changed these up like last year because we noticed that we were just giving y'all all column proofs. But sometimes they like to give y'all paragraph proofs on y'all tests. Not hard. Same thing. It's just in paragraph form. And with the paragraph proofs, you usually get a word bank. Same with these, but it'll be like drop down boxes, and you'll see them. I think we did it like that online for y'all. But you usually get a word bank with paragraph proofs, and you just got to figure out what's what. Jalen. This one says, given KM is congruent to NM and LK is congruent to LN. Prove triangle LKM is congruent to triangle LNM. So the first part says KM is congruent to MN. That is what? given. So yeah, a lot of kids like to put letters up there, but I guess you can because you probably won't be able to fit the whole thing. Guess I'll be okay with that. So E, given. Then it says blank is also given.
Okay, it's congruent to LM.
Which is what? I'll write the letter then. G. After that says LM is congruent to LM. LM, 7 LM is congruent to LM are congruent by the blank. I'm sorry? No, girl. By the blank property. Reflexive property, yes.
I read it wrong.
It's okay. I was reading it wrong at first too, and it didn't make sense to me. And then it says therefore. Oh, we're doing all that, and I ain't marked nothing on my figure. See, this is what I talk about. If y'all see me not doing it, y'all gotta call me out because I won't do it, and some of y'all won't either. And you're gonna be messed up when you get to the end. So starting out, the first thing it told us KM was congruent to NM. We should have marked that first. Then they said LK was congruent to LN. We should have marked that. Then they said LN was congruent to LM by the reflexive property. We should have marked that. And then it says therefore LKM is congruent to LM in those triangles by which triangle congruency? Side. I thought you was joking. Yeah, side congruency. So that's the ones where you got that's a paragraph proof. Same thing. Just some paragraph form. Alright. I'm done now. I'm sorry for being so long-winded, but I got to put you in the right position. Don't worry though, I won't be talking at all tomorrow.